Hi there guys, this is again a video to do some prelim prep for paper 1, and I'm going to look at 2014 Sakai prelim exam, which is this one, and comment on students submissions for this. Unfortunately I can't talk about students because only one student have submitted anything to comment on, which is very disappointing. I'm really hoping you guys would participate in the preparation phases, but I know there is some challenges as still some of you are trying to finish the course. So let me honor the one student and then comment on his submissions. Okay, first of all we are looking at solving equations, and he's doing very well. Here's my equation to solve, simplify, get it into standard form, factorize into 2, and these are my two brackets, x minus 4, x plus 4 and x minus 2, which solves to that. This is the next one, very simple, straightforward question. Substitute into a formula, and it's just easier because we have the coefficient of not an a. Substitute in, getting those two answers and rounding them correctly to 2 decimal places. Here all of a sudden we have a quadratic inequality. Very important. Once we have a quadratic inequality, it works exactly the same up to this point, and then everyone goes and say, well, now x is equal to a third and x is equal to 1, or 3x minus 1 is bigger than 0, x minus 1 is bigger than 0. That's not how inequalities work, and the student is doing it correct by rather taking the how it works is, once you have it at that point, you draw a parabola, and then you have your two intercepts on either side. The one intercept, this one is the smaller one, which in this case is a third, and the bigger one, that does it, and the bigger one is 1. And so if we look at this, we're using everything bigger than 0, so that's everything above the x-axis that's bigger than 0. That means if I look at my graph, it is associated with everything below x minus x is smaller than a third and x is larger than 1. Okay, so and included because of the included sign there. So that's why this is the correct answer. Well done. Then next question. Okay, if I look at the question paper here, we solve x and y simultaneously. So I'm trying to find the solution for x and y at the same time. And I think there was a problem in the paper here. I think that had to be -2. Yes, let me just correct that. That should have been a y plus 1. Y plus 1, I look now. So, but nevertheless, you could have done both. It's still done it. It just didn't have nice answers, but that should be a y plus 1. And so the student did very well up to this point, and then he didn't know how to go further. First of all, what he did is, instead of treating getting y on its own and substituting, because now this is our problem, is we all of a sudden have our unknowns in the exponent, and so this is a complex question, and what he then instead did is just get 5y on its own, and then in the second equation to get the 5y plus 2, the 5y can then be written as, we can break this up, we can factorize this into 5y times 5 to the power 2. And then he substituted this 5y with the 9 minus 2x. That's what he got here. But what he should have done is just put this in a bracket. And then he should have just gone on. All you need to do now is get 2 to the power of x by itself. So remember, when I'm trying to solve an exponential equation, I try and get the base exponent pair by itself. So let me take his question from here and show you how you would do that. It's really that simple. So if you didn't know exactly what he's doing here, just have a look. But I'll do it, pause the video and have a look there. I'll do it from here. We have 2 to the power of x times a half plus, and this is what is substituted, 9 minus 5, let me see, 9 minus 2 to the power of x, and times 25 is equal to 9. 9 times minus 2 to the power of x, and then this 25 is as a result of the 5 to the power of 2, but this should just be 5 to the power of 1, because that should have been 5y plus 1. That was changed to 5y times 5 to the power of 1, and this is equal to 9. And so how would we go ahead and solve this? And say 2 to the power of x, then the half is just the coefficient. Now my suggestion is, the moment I have something that I want to get by itself, if it's not something simple like x or s or t or something, then replace it with it. Then I just say let s equal 2 to the power of x, or k. It's often called the k method. So k, so it's a half k plus 9 minus k times 5 is equal to 9. And now I have to solve for k. How easy is that? Okay, that's grade 8 stuff. So I just multiply out. I get a half k plus 40 minus 5k is equal to 9. So I'm just going to multiply everything with a 2 to get rid of this silly half. I don't like working with fractions. K plus 80 minus 10k is equal to 18. And then I'm going to simplify. I've got 8 minus 10 is 9. Negative 9k is equal to, and then on this side I've got, I just see I've made a silly mistake here. 5 times 9 is not 40, it's 45. Sorry about that. That's 45, and so 45 times 2 is 90. Okay, sorry about that. And then negative 9x, this gives me 72, negative 72, and then k is equal to 8. Okay, because 72 divided by negative 9 is 8. So in other words, and remember what k was, I said less s. That was silly to let k equal that. And then here I've got that k used to be 2 to the power of x is equal to 8. And so 2 to the power x means that x must be 3, because 2 to the power of 3 is equal to 8. So there I've got x, and now I can just go back to my original equations was 2 to the power x plus 5 to the power of y is equal to 9, and I can just replace it in here and say, well, 2 to the power of x is equal to 8, because 2 to the power of 3 is equal to 8, plus 5 to the power of y is equal to 9, and so 5 to the power of 9 is equal to 1, because 8 plus 1 is 9, and so y has to be equal to 0, because 5 to the power of 0 is equal to 1. And so there's your two answers. X is equal to 3, and and y is equal to 0. Okay, if it was plus 2, it would have worked exactly the same, but your x would have been an ugly number, like I can't remember what it is, but nevertheless your methods would be exactly the same. And that was this question. Next one, when x cubed plus px2 minus 5x plus 14 is divided by x minus 2, the remainder is 8. Determine the value of p. The student went and wanted to divide. There's a way of doing it like this, but it won't work. It's too complex. There's such an easy way if we just know our theory, guys. And please, when we attempt these these prelim prep papers or even final exam prep papers, don't stop it there. Go find the answer. X cubed minus px squared plus px squared minus 5x plus 14 minus 5x plus 14. If this is divided by x plus 2, and so what we should do is we just call this fx, and then you know that the remainder theorem says that if I take my divisor, which is dx, if I take my divisor and make it equal to 0, x plus 2 is equal to 0, and I solve it, x is equal to negative 2. If I substitute this value into f, I get my remainder. So if I substitute this in here, I get my remainder. And my remainder is 8. And it's an equation. I just solve for p. So I get negative 2p, and then here I get negative 8, which can go to the other side to become 8, positive 8. Here I get positive 10, which becomes negative 10, and positive 14, which is negative 14. So 8 and 8, that's 16. 16 and negative 14 is negative 2. Positive 2. Positive 2 and negative 10 is negative 8. So negative 2p is negative 8. And so p is equal to positive 4. Okay, let me just check my calculations. That's negative 24, positive 16 is negative 8, is negative 2. That's perfect. Okay, so again, I need to know my theory. Okay. Question 2, 1.4, the solution of a quadratic equation is given by here. For which values of r will this equation have 2 equal roots? Okay, now we have equal roots when my plus minus that expression is 0. So I'll have equal roots, let's just see, when that expression exactly, that expression here, 2r plus 5, when that equals 0. When will that equal 0? When r is equal to negative 5 over 2. Excellent. Next question is, when will it have no real solutions? And the student is not 100% understanding. It's when what is under the square root is smaller than 0. So it's very simple. If it's equal to 0 when it's that, then it's smaller than 0 when r is smaller than negative 5 over 2. Okay? And that's how simple that is. That's why it's just 1 mark, because you've already got the critical point where they have equal solutions. And now no real solutions is when it's less than that. Okay. Consider okay, question 2, 3, and 4 I think were question 2 and 3 were number pattern questions. I'll answer them in the next video.